Welcome to geometry class. Today we need to talk about what is necessary and required to distinguish between different properties or different parts of the triangle. We've been talking about a lot of lines and line segments that run in and through triangles. We've also been talking about a lot of points inside triangles, sometimes outside triangles. So we need to find a way, we need to make sure that we can distinguish between all these different things. So I've titled this particular video Distinguishing Between Mid-Segments, Perpendicular Bisectors, Angle Bisectors, Medians, and Altitudes. It's quite a mouthful, but it's important because if we can distinguish between those different segments, then we should also be able to distinguish between vertices, midpoint, circumcenters, incenters, centroid, and ortho centers. Remember, when we talk about these last four, circumcenters, incenters, centroids, ortho centers, these are all points of concurrency of certain specified lines or segments in the triangles. So if we can tell the difference between these different points, we should be able to figure out which lines we're looking at. And if we know which lines we're looking at, we should be able to figure out which points are which. To get started, we're just going to take a look at a diagram. Here it is. Rather complex. I'll often say that problems that we deal with in school are usually much simpler than problems that we deal with in real life, because in real life there's all sorts of information coming at us that we need to be able to distinguish between and among. So in this diagram you can see there's quite a bit of information in here, a lot of different lines going on. Let me just talk about a couple things that we should be aware of. First of all, there are not a lot of givens in here. You see a lot of line segments, but not a lot of given information. There are a couple things. We've got a few right angles here pointing at us. And we have some parallel lines. And other than that, we might just take note that this point right here, in the center more or less, which is sort of a relative term at this point, is point I. That's point I, and that's what that little line just means, that that's point I right there. So, not a lot of given information. First thing we might want to ask is there any other information we can sort of extract from this and be certain of? And the answer to that question is yes. First of all, if we look at these two parallel lines here, we know that this line C, we'll call it line CJ, goes from point C through J here. That's perpendicular to side AB, and it's also parallel to this line HE here, which means that HE must also be perpendicular. So we can just go ahead and put that in. It's a set property of this particular diagram because of what is given. What else? We also see these two parallel lines here. That is line BJ and line, I guess that'd be line HD, we wanted to name it. And because HD is perpendicular to AC, and we know that this line BJ is also parallel to HD, we can conclude in this diagram that line BJ is perpendicular to AC. So that's about it. We don't really have much else. We've got two additional perpendicular lines to go with. What else can we conclude? Let's just start with this question. Can we find a circumcenter in this diagram? Is it possible to find a circumcenter? Well, if we wanted to find a circumcenter, we need the point of concurrency of the perpendicular bisectors. So all we need to do is look for the perpendicular bisectors. Well, I have AF here perpendicular to CB, but I don't know if CF is congruent to FB. I don't know if that's a perpendicular bisector. We could ask the question, does that mean that we can't find the circumcenter? Well, in and of itself, that fact does not mean we can't find the circumcenter, because if we find two other perpendicular bisectors, namely the perpendicular bisector AB and the perpendicular bisector AC, if we can find those two, then we'll know where the circumcenter is. But again, over here, you can see this segment, EH. It's actually it's a segment on EH. It's unlabeled at this end here. That's perpendicular to AB, and it looks like it might be the bisector, but we certainly don't know whether it is the bisector. We don't know if AE is congruent to BE. So if we were to ask the question, can we identify any perpendicular bisectors in the diagram? The answer is, well, no, we can't. We don't know of any. All right, let's ask a different question. Can we identify any ortho centers? That's a question. Can we identify any ortho centers in this diagram? Well, let's take a look. The ortho center is the point of concurrency of the altitude, so we need to find 2 or more altitudes. And we find any altitudes? That's the question. Notice how the first question devolves down into the second question. Do we have any ortho centers? I don't know. Do we have any altitudes is the question. Let's see if we have any altitudes. An altitude is a perpendicular segment from a vertex to the opposite side. So we have a perpendicular segment here, perpendicular to AB, which goes through or to point C, so that's an altitude. And then we have this AF, which is perpendicular to CB down at point F, and that goes to the opposite vertex. There it is. That's an altitude. And with that information right there, we can already be certain that this, point J, is the ortho center. So that was an easy one. Let's ask the question about any incenters. Do we have any incenters? Or what do we need to find in order to locate an incenter? We need the angle bisector. So the next question becomes, are there any angle bisectors? We need at least 2 of them. Well, on the information in the diagram, as everything stands right now, the answer is no. We could look at vertex AF here, and if we knew that angles CAF were congruent to BAF, then we'd know we have an angle bisector, but we don't have that information. So let's just stop there. At this point, hopefully it's pretty clear that I don't have any identified angle bisectors in the diagram. But let's take it a step further. Suppose that I gave you additional information. Suppose I said that the measure of angle ACI is equal to the measure of angle ICB. Suppose I also told you that the measure of angle CAF is equal to the measure of angle BAF. So what do we have with these new givens? We have CAF, the measure is equal to the measure of angle BAF, so therefore those 2 angles are congruent. Which means, by the way, if those 2 angles are congruent, that means that AF is the angle bisector of CAB. So we have 1 angle bisector. And then if we look at this first given here, measure of angle ACI, ACI is congruent to ICB. That's actually this angle. That means that this segment here that goes from C and passes through I to the other side here at this unnamed point is also an angle bisector. So that's an angle bisector as well. Well, what does that mean? It means that point I must be the incenter. You can see, depending on the amount of information that we're given in the diagram and the nature of the diagram itself, there are times when we're able to find certain points, and there are other times when we're not able to. The test of whether you really know this material is whether you can look at a diagram like this and begin to analyze it. Or can you look at a diagram like this and be given some extra information and begin to analyze it? So what would be a good idea at this point is for you to just sort of play around with the diagram. Ask the question. Here's the question you should ask. What information do I need, or what would be the minimum amount of information that I need to identify a circumcenter, to identify an incenter, to identify a centroid, to identify mid-segments? By the way, remember, there's these different points in here. So vertices, hopefully that's easy by now. Those are the 3 corners of the triangle points, A, B, and C. Mid-segments, of course, there are none identified here, but if I came along and told you that AD was congruent to CD, and of course it's a little difficult in the diagram just to show because what we need is congruence here, not just here. But if I told you that AD was congruent to DC, and if I told you that AE was congruent to EB, and if I also told you that CF was congruent to FB, then I asked the question, are there any mid-segments? The answer is yes, because we have a couple midpoints. D is now a midpoint, E is a midpoint, F is a midpoint, and so of course DE, EF, and FD are all mid-segments. Likewise, if we ask the question, I don't think I mentioned this before, but how do we find a centroid? Well, on that basis of the information I've already told you, we could ask the question, is the centroid identified in this diagram? The answer is no, because we know that a centroid is a point of concurrency. The medians, and one of the medians, for instance, would be median CE, since E is now a midpoint. If I can draw that in, my median here, CE, is actually concurrent with the median AF, because AF is a median, with this unnamed point right here in the center. So with a fair amount of ease, we can work with new given information to find new points and new information in the diagram. I strongly recommend you work through that process of asking those questions. What information do I need to find these different points, these different lines, these different segments in the triangle? Work through that. If you have an opportunity to pair up with a friend or work with someone and have them quiz you or test each other and see if you can mess with each other, that's always a good idea. If you have any questions for me, of course, you're always welcome to send me.